friends. Today I'll be telling about ANOVA. How to use ANOVA in R. ANOVA is actually extension of t-test. So in t-test we compare two groups, but in ANOVA we compare more than two groups. Whether there is difference in the means of these different groups. Okay, suppose A, B, C, three groups are there. Whether there is difference in the mean of these three groups. Okay. So this is an extension of two sample t-test, and then null hypothesis in ANOVA is the means of different groups are the same, and alternate hypothesis at least one sample mean is not equal to others. Okay, so this is ANOVA. This is the basics of ANOVA. Okay, so we did what we did in t-test, that is two groups, but here there are more than two groups. That's why we use the ANOVA. Okay, and these are the libraries, and now we take the plant growth data. Okay, so you can see. So suppose you type summary, and then you can see the group. The two columns are there, weight and group. In the group there are three groups, each group with 10 each. Okay, so weight is numeric. Okay, that's why it is showing the mean and row. Okay, now you can see the random samples. Okay, random rows from this my data. Okay, just 10 random rows are shown. Now you can group this my data by column group, and you can summarize that. For each group, what's the count, mean, standard deviation, and you can also use the ggboxplot. Okay. You can just see the box plot here. Okay, because my video is coming, I'll just zoom and I'm just showing this. Okay, so this is the box plot of the three groups. Okay, treatment 3 control, treatment 1, treatment 2, and this is a box plot. Okay, weight. So, and now you can compare the mean also with this. Okay. Mean, how the means are differing. Okay. Just a minute. So now we are going to find the ANOVA. So here we are going to compare the weight versus group. Okay, group we have got three factor. Okay, so we are going to compare weight versus group. So this is a command. AOV is the command, and that is stored in res.aov. Okay, so we are going to find the ANOVA, and then we are going to display the results. So as you can see, degree of freedom is 2. 3 groups are there, so 3 minus 1, 2. And then independent variable, then we have considered 3 groups, that's why minus 1. So 2 is the degree of freedom. And then the residual, sum square, mean square, and then this is the test at 6 f value, and this is the p value. So this is less than 0.05. So we go with the alternate hypothesis. Okay, so as the p value is less than the significant level 0.05, we can conclude that there are significant differences in between the groups. Okay, so So that's what. Okay. You can plot the result and then see whether how the cookie plot and all are displayed. You can see how the residuals versus fitted is plotted. Normal QQ. See, you can see the outliers. For in the previous diagram also you could see 4, 5, 4, 15 and 17 are outliers. If you remove those things, you will get a good normally distributed. One condition is that it should be normally distributed. Okay. What all condition for the t-test, those conditions should be met here also for each group. Okay. So now I'm going to import one new data set and show another example. So this is the CSV file, density, block, fertilizer and yield. So these three are variables that can be factorized. Okay, density, block, fertilizer, and yield is a numeric value. So let us see that. So this is the command for reading. So here we are telling first three are factors and the last one is numeric. So I am copying that data and then I am showing the summary. So you can see here two groups are there, 48 each, two groups, and block variable 4 groups are there, fertilizer 3 groups, and yield is a numeric. Okay. So in the one-way ANOVA, we test the effects of 3 types of fertilizer on crop yield. How these 3 are affecting the yield. Okay. So this is the command for that. One-way ANOVA, and you will get the summary. So the p-value is very much less than 0.05. So we'll go with the alternate hypothesis and we say fertilizer has got a good effect on the yield. Okay, that's the alternative hypothesis. Null hypothesis, there is no effect, and alternate is there is effect of fertilizer on the yield. Okay, now we are going to show you the two-way ANOVA. So this is the command for two-way ANOVA. So here fertilizer and density. Okay, how that is going to affect the yield. So you can see here p-value, both the p-values are less than 0.05. So both has got an effect on the yield, and also you can see the residuals here 35.89 has been reduced to 30.765. So adding this variable is good for the model. Okay. So this model is better. And whether there is an interaction between fertilizer and density. So for that, instead of plus sign, you have to put asterisk here. Okay. Yield versus fertilizer star density. Okay. So you are going to find whether there is any interaction between this fertilizer and density. Okay. So the summary. So here the fertilizer density interaction p-value is higher than 0.05. Okay, so there is no interaction between fertilizer and plant density. Okay, I hope you understood. So ANOVA, so just a recap, ANOVA means extension of t-test. So you are going to compare more than 2 groups and see whether there is any difference in the mean of these groups. Okay, so here what we have done in the second example is we are having more than 2 groups for the fertilizer. Okay, and we are seeing whether this fertilizer and density is affecting yield. Okay, one way ANOVA and two way ANOVA. Okay, I hope you understood. So just one simple, it is very simple, just one command. Okay, AOV is the command, and then you see the summary of the result. That's all. If you got any doubt, just comment, I'll reply. So this is the ANOVA. Okay, ANOVA in R. Thank you very much.